This is an electron diagram, or a diagram of an atom with electrons being highlighted here, and the focus of this video. This diagram is an oversimplified model that greatly exaggerates the size of the nucleus relative to the volume of the whole atom. Quote from Lisa A. Uri: if an atom of helium were the size of a typical football stadium, so if we had a football stadium, and the nucleus would be the size of a pencil eraser in the center of the field. So in the center, it would be like a tiny pencil eraser. That would be the nucleus, and the whole field would basically be the interatomic space. Oh, that's what you would say. And then the electrons would be like two tiny gnats buzzing around the stadium. Atoms, something they should really know, are mostly empty, oh my god, I can't spell. Space. That was hard to write. Okay. Nuclei, when two atoms are interacting, so let's say this is atom 1 and this is atom 2. When they are interacting, their nuclei, which I'll draw in pink, do not interact. They do not interact. Only their electrons around it interact in chemical reactions. Okay? And electrons vary in the amount of energy. In the amount of energy that they have. Energy is basically the capacity to do work, to cause change. So basically, it's like, how much change can I cause with energy? And if we see something that will come in very frequently is potential energy. It's energy that matter, like let's say our box, possesses because of either its location. Location is one factor, or because of its structure, which is a second deciding factor. Structure and location, potential energy. That's the amount of energy it possesses because of these two factors. I'll see an example. So let's say that we have a hill here, and then we have some generators down here. I don't know what generators look like, so I'm just drawing something random. And then we have a bucket of water in here. So let's say someone tipped over that bucket. And then we have all of this water just rushing down. Let's look at this, and it turns on the generators. So looking at this at an energy view, we would say that water, when it was up here, it had a high potential energy because it had a high altitude. And if it had a high potential energy, that means it can do more work. It could do more work. And then because it had a lot of potential energy, it had the potential to turn on our generators here. And now when it came down here, downhill, now it had less potential energy because it has a lower altitude. So the higher something is, usually the higher the potential energy is. So matter's natural tendency is to go from whatever highest possible energy it has to the least possible energy state it can be in. Now let's say you want to bring this back. So you want to bring this guy back. You want to bring the water back. So you can do it all over again and turn them on again. Well, you will be having to add energy and do work if you want to make water go against gravity and go uphill. You're putting more energy to do that. Electrons have potential energy. So now let's go back to electrons. So they have potential energy due to their arrangement. Electrons, which are negative, are attracted to protons, which are positively charged. Now, if something is attracted, so in the nucleus we have a bunch of positive and neutral charge, which basically makes the nucleus positive. And if you have electron, it's going to be attracted to it, and that kind of creates a tension, which is calculated in an energy matter. What that basically means is that to move electrons away from nucleus, if you wanted to move away, because of their attraction, it takes a lot of work. So this could be like our gravity in our water situation. This is our force that's causing us to add an input of energy to cause an electron to move farther away from the nucleus. So you need to do more work. The more distance between an electron and the nucleus means the more potential energy. So now we're looking at location, but not a hill type of thing like high altitude. But the farther away it is from the nucleus, our weird nucleus here, the more potential energy that it has, meaning the more work it can do. So when we look at this, changes in potential energy can only occur in steps. So let's do a model to show what I mean. What I mean is that if we have an electron, it can only stay and have energy on a step. It cannot be in between a step. If electron was a ball and we imagine it cannot be in between the steps. So what that's trying to say is that changes in potential energy, so I'll just draw this to show changes. And potential energy occurs in steps. So it occurs in steps and also fixed amounts. It occurs in both. So you can have energy and spend time between steps, but you cannot be in between the steps themselves. Electron potential energy is determined by the energy level. So we have different energy levels, and then we have the nucleus here. And we have different energy levels, like between here and between here. Like that, different energy levels between them. And distance from the shell, so electron distance correlates with electron energy. Electron shells are where, so we call these electron shells, and these are where electrons are found. They're in here. They cannot be in between here. No, they can't. They can only be on like the shell area. So if they are, let's say for example, if we had an electron here and we had an electron here, this one has more potential energy, meaning it could do more work than the one here. So this one, has less potential energy. And it could change its shell that it's in. So this one can like jump here and then here, or vice versa. The other one can jump from here to there. But they have to absorb or lose energy. So let's say an electron here wanted to go here. So this one wanted to go here. It has to absorb energy to do so. If it absorbs energy, then it can move further away from the nucleus. For example, light is what gives the energy to an electron so it could finish its process, and not phosphorylation, sorry, photosynthesis, for example. And if you want to do the other way, then it would have to release energy. So electrons closer to the nucleus basically have lower potential energy, farther have more potential energy, something you should remember. So for an example, let's say we had a beautiful red car that kind of looked like that. And then you have a lot of heat from it, and it's really hot. That is because when the electrons are dropping back to their lower potential energy, or basically closer to the nucleus, and when they do that, they release energy because they're going to a more closer state to the nucleus.